Okay, we are going to look at solving a system of equations using elimination and then using substitution. Now the first one, we have two equations with two variables, and what we might notice is, well, we got a negative 5y and a positive 10y. So we're going to use elimination in this problem. In order to use elimination, what we want to do is to be able to add the two equations so one of the variables eliminates. So let's check out the y, because they already have opposite signs. And in fact, if I doubled that, they would cancel. So what I'm going to do is double that whole equation. So let's do that down here. 16 minus 16x minus 16x minus 10y, see, even I make mistakes, equals 22, and I'm leaving my other equation alone, minus 2x plus 10y equals negative 1, and I always like them to have opposite signs because I like adding them, but that's, if they have the same sign, you could just use subtraction. I'm basically going to add these two equations together. So 16x plus a negative 2x is 14x. Those cancel. Equals 21. I can now solve for x. So I'm going to divide both sides by 14, and I get x equals 21 over 14. Both those have a common factor of 7. So 3/2. Now we do need to go and find y. I can plug this into either of my equations. I should get the same value of y if I solve this first part correctly. So let's use this second equation. So negative 2 times 3/2 plus 10y equals negative 1. And now we'll simplify. The 2's will cancel. So we have negative 3 plus 10y equals negative 1. So we're going to add 3 to both sides. So we have 10y equals 2. Or, when we divide both sides by 10, we get y equals 1/5. So what we've found is the solution to this system of equations, or the point of intersection of these two linear functions. Now we're going to do this again using substitution with a slightly different example. Y equals x plus 1 is one of our lines. The other is 2x plus 3y equals 12. Now this is already solved for a variable. If it wasn't, we would take one of our equations and solve it for a variable, and then you plug it into the other. So we're going to do this second equation with x plus 1 plugged in for y. So 2x plus 3 times x plus 1 equals 12. And now we do need to get rid of those parentheses. So I'm going to distribute the 3. So I have 2x plus 3x plus 3 equals 12. So we can combine the x's. We get 5x. Let's go ahead and move this 3 to the other side. So subtracting 3 from both sides, we get 9. So 5x equals 9. Dividing both sides by 5, we end up with x equals 9/5. Now we have to use this to find y. The one nice thing about substitution is we've already solved for the other variable in terms of x. So we just need to plug that guy in to our equation. We know y equals x plus 1. So y equals 9/5, what we found for x, plus 1, which is 9/5 plus 5/5, or 14/5. So there's our x and y. A solution to a system of equations, linear equations, will always have two answers, an x coordinate and a y coordinate, or an input and output, we could think of it. because we're looking at a point of intersection.